right, how's everybody doing today? I had a student reach out and ask if I would do question 2D from the assignment. After I posted the answer key, I reached out back to the student and they said they'd appreciate to see how I did it in real time. So I'll post a video and you guys can take a look. And if anyone wants me to do any other questions, again, just do the same thing. Reach out, let me know, and I can show those. Okay, so how are we going to deal with this question here? So again, if I compare the left-hand side to the right-hand side, to me, it seems like we have to start with the left-hand side. Like, there's no way very obviously saying that this thing can turn into that. But what we can do is we can start working with these cosine 3x's, working with these sine 3x's, and breaking stuff down until eventually we get to the point where maybe we'll see a more obvious next step. And again, like I was talking about in class, sometimes seeing something that's a really obvious first step might be a really obvious last step going the other direction. So again, when I look at this cotan 2x, what that tells me is my second to last step is going to be making it 2. Sorry, let me just switch this over. 2 cos 2x over sine 2x, right? So if that's the case, if this is what we're trying to get it to, well, let's see if we can't work with the left-hand side and make it turn into that. So cos 3x over sine x plus sine 3x over cos x. Alright, so again, when we're dealing with something that's not a 2x or not a sum, right away our identity doesn't work the same way, right? You can't say cos 3x works the same way as cos 2x because that's not the identity. So what we have to do is we have to take this cosine 3x and break it up into 2x plus x. And that's still over sine x. And we're going to do the same thing with the sine 3x. So sine 3x is 2x plus x over sine x. Okay, so now we're going to use our sum identity. So we'll say that this is cos 2x cos x over sine x minus sine x sine 2x over sine x. Okay, and you'll notice that I took this fraction here and I broke it up into 2 right away. The reason I did that was because before I started with the identity, I recognized that we're going to have a sine x here, and we're going to have a sine x there. So if I break it up right now, what I can do is start canceling things and simplifying things. Let's take that and move it over to give myself a little bit more room to work. Alright, and then that plus sign is still there. And again, what I'm seeing here is that when I apply my identity, I'll probably have a number of sine x's that can cancel. So let's split that up the same way I did the previous one. So this is going to be sine 2x cos x. Oops, sorry, this is supposed to be a cos x here. Over cos x plus sine x cos 2x over cos x. Right, and what I see right now is that sine x is going to cancel out with sine x, and cos x is going to cancel out with cos x. And when I do that, what I end up with is a negative sine 2x here and a positive sine 2x there. So what that means is that this is going to end up canceling out with that. So now my next step is going to leave me with cos 2x cos x over sine x plus sine x cos 2x over cos x. Okay, so now again, what I'm going to want to do is take these double angle identities and start splitting them up. Actually, let me just give me a second here. Instead of splitting them up, what I recognize right now is that if I combine these two fractions at this point in the question, right? If I say that, okay, well, here's a fraction with a denominator of sine x, here's a fraction with a denominator of cos x, what would happen if I added those two? And the reason that I want to do that right now is if I look at this question, here I've got a cos 2x, and here I've got a cos 2x, and what we said earlier from the start of the question is that I want to have a cos 2x in my numerator. So instead of trying to use your double angle identity to split this thing up, let's see what happens if I add these two fractions. So if I add them, what do I get? I get cos 2x cos squared x plus cos 2x sine squared x. And this thing is all over sine x cos x. Alright, now if I factor out a cos 2x from the numerator, I get cos 2x times cos squared x plus sine squared x all over sine x cos x, which is nice because cos squared x plus sine squared x is equal to 1. So now I am just one more step away from trying to turn this thing into my identity. Now why is that? It is because this thing right here is not quite the double angle identity, right? We know that the sine of 2x is equal to 2 sine x cos x, which means that this thing is actually half of my identity. So if that's the case, if I were to take this and try to use the identity, instead of getting sine 2x, what I get is cos 2x over half of sine 2x. And what that means is this half, if I move it up to the numerator, we take the reciprocal, so now we have 2 cos 2x over sine 2x, and then finally apply my cotan, my quotient identity, and this thing is 2 cotan 2x, which is the right hand side. Q, E, D. Okay, so a bigger question. I think the value of that question on the assignment was 7 points, so it makes sense that there would be a number of steps involved in this. So if you did struggle with this question, that's fair. It's one of the ones that are put there to really challenge you guys. But hopefully that was clear. Hopefully you guys were able to follow along. If anybody, like I said, has any more questions, feel free to reach out, and I will be happy to make more videos with answers. Alright, expect a video probably tomorrow or Friday, just kind of with the new topic, which is going to be series, and expect probably 1 or 2 more next week as well, and that way when we come back, hopefully in a week and a half or so, we'll be able to not be too far behind. Alright, have a great day everybody, and see you soon.